Hey, what's happening, guys? This is the GIKFUN Christmas tree kit that comes with absolutely no instructions whatsoever. So I thought maybe it'd be fun if put it together and we could take a look at it and go over it. One of the main things you're going to find confusing is the fact that they've labeled about half of the resistors. The other half have no label whatsoever. That's, not a great thing, really, right there. So we're going to figure it out because there's some information out there on the web. But, if you got one of these kits and you want to put it together yourself, or you got it for a friend, or, whatever, we'll help you figure it out and put it together. So I'm just seeing how these things fit together, what the alignment has to be. There's some arrows. I want to make sure things point in the correct way so that the positive and negative feet pads go into the right receptacles so they either receive VCC or ground. We don't want to hook them up with a reverse polarity. That probably wouldn't be very good. So that's what I'm doing here. Just checking to see how everything fits together. Now I think it's time that we start laying everything out. What's known as knolling. It really helps to have all the parts laid out so you can see them individually. They're identified. You know what their values are. And it makes things easier to put together. So that's what I'm going to do now. I'm going to get all these parts out. And there's really not a lot of parts. The main parts you're going to find are the LEDs. There are, I think, 36 LEDs, so 72 LED joints that need to be done. Ready? All right, here comes the knolling. First thing I'm going to do is put these screws together so I don't lose them, because I tend to lose things quite a bit. Especially little tiny screws, and my eyes aren't that good, and my fingers are like big sausages, so I know this hit on the floor, man, it's going to be almost impossible to find. I'm also getting out the DC jack and the switch, just kind of getting things where they go. These are all the pieces that go over there with the battery compartment, and then we're going to put the other things here and have them all laid out as well. So I want to put the nut on there. How tiny they are. It's probably like a 2mm screw. Way too tiny for my big fingers, but that's the way it goes. Alright, you don't have to watch me do this. Pop! There it is. Everything's knolled out. And I even took the resistors, 10K, what's that, 1K, 2K, and 330. I measured them to make sure what each different resistor was. These are 9 of 14 transistors and the 47 microfarad capacitor. So far, so good. Everything's pretty simple. I'm getting my soldering stuff out. I am using 6040 lead tin solder. It's from MG Chemicals, 0.032 diameter. I am using an adjustable temperature soldering iron, and I have it set for 350 degrees science. We're going to start with the lowest components on the board, which are the resistors. In this case, I'm starting with the 10Ks because, they're marked and they're easy to find. Resistors are not polarized. That means it doesn't matter what direction you put them in, which leg goes in which hole, it doesn't matter. A resistor resists current, in case you're wondering. And they do that by exchanging current for heat. A resistor basically is a heater. The wires that you find in your hair dryer at home are resistive elements. So that's all we're doing with the resistor. We're controlling how much current gets to the LED, because the LED itself will take as much current as you want to give it until it actually explodes. Like, not a dangerous explosion. What you generally get is just a bright flash of light and it never turns on again. But internally, it's exploding. It's blowing apart its internal connections because of too much current. Think of current as the flow of water. It is the force of the water. Voltage is how far the water falls. You get a higher start, you get more voltage. But it is the flow of the water, the current, that's doing it. So I'm getting all these resistors in here, and I'm going to lay them down flat. And you're going to see how I'm going to flip them over. And what I want to do is I want to solder just one leg of each resistor. Then we can flip the board back over, take a look at it, and make sure they're lying flat like we want them to. Sorry, sometimes I know I don't have my hands in the camera. Sorry, there's also no production value here whatsoever. There's just me. There's me. Well, there's Dog, but she's not much help. She mostly sleeps on the couch unless she wants something to eat or go for a walk. But I'll tell you this, she's real cuddly, and that has its own advantages. On a cold night, nice dog curled up down by your feet, keep your toes nice and toasty and warm. All right, next we're putting in these ones. What are they? I can't read what that says, but whatever they are, that's the ones we're putting in next. Just matching them up to where they go on the board, folding the legs over at 90 degrees real flat. Don't worry, this video is not going to take 3 hours. It's going to take, about 20 minutes by the time we're all done. I'm showing you this so you have a basic place to start from. Then we're going to move up and things will start happening relatively quickly. So first of all, we're just going to put in all the resistors. Once all the resistors are in, we'll check them just to make sure there's no solder bridges, no shorts. And then we will move on to our next step, which I think we'll, I don't know, maybe do the transistors next, but we just want to make sure we got all these. Other than soldering in the LEDs themselves, getting all of these resistors in the right place is easily the most difficult part of this build. See, that one I didn't have in there very nice. So you just got to heat that one leg you did and just kind of push it in once it's hot. It'll go in real nice. There won't be much of a problem. But if you solder them both in, you generally will have a problem. So that's why I don't do that. Then we'll cut the legs off and move along. All right, sorry for the interruption there. We just need to finish soldering these guys up. And you'll find after you've soldered for a little while that it's not hard at all. And it's actually quite relaxing. Just remember, certain components are polarized, which means they have to be installed with their positive end facing one way and their negative end facing the other way, or they won't work. This is especially true of anything that has what's called a p-n junction, like a diode or a transistor. And keep in mind that LEDs are diodes, so if you hook your LED up, it will definitely not work. Now I'm using these flat bottom nippers, and you want to hold them parallel to the surface of the board. And then you cut off the excess. See how simple that is? If you don't have flat bottom nippers, you can get away with any kind of wire cutters. These just make for a nice, neater job. They're relatively low cost, like I think like $7 or something like that. It's not too bad. Okay, everything's nice, soldered in, ready to rock and roll. We're going to move on to the transistors. In this case, the transistors are acting as a switch. They can also act as an amplifier, but in this case, they're acting as a switch. They have three connections: the collector, the emitter, and the base. The electricity or the current will flow in through the collector and out through the emitter. The amount of current that flows is controlled by a smaller current that you place on the base, and you have a proportional increase. That's why it can be used as an amplifier. In this case, however, we're simply hitting it with a single level of a current that turns it on like a switch. Transistors can be used either as a switch or as an amplifier. Now, it's important, remember I told you a couple minutes ago that they're polarized, so they have to be placed in the board facing the correct way. Now, the silkscreen on the board for the footprints of these components, and the footprint is how the component is going to fit to the board. So these have a nice silk screen. They have a round back and a flat front. So as long as you align them correctly, there won't be a problem. Now, one thing to keep in mind when you're soldering things like this is the biggest enemy of any electronic component is heat. So we want to keep the heat down to the least amount of time possible. Now listen to that, the least amount of time possible, not the least amount of heat, the least amount of time. So I mentioned earlier in this, I keep my soldering iron at about 350 degrees Celsius. That generally provides enough heat for anything we need, and it allows for a very short dwell time, which means the time that we actually apply heat to the component. And that's what you want to look for, a short dwell time. It is much better to turn your iron up to, say, 400 degrees Celsius and cut your dwell time in half than to double your dwell time at 350 degrees Celsius. The heat input of the higher temperature, shorter time is much better for the components. Then we just nip off the excess just like we did with everything else. And that's really all there is to installing them, nothing special. Okay, so they're both in for both boards, and hopefully I put them in the correct direction. I think I did, but you know, you just never know. So now we're moving on to capacitors. This is a DC, a direct current device. It's not AC alternating current like what you put, like what comes out of your sockets in the wall. So in DC, a capacitor simply is going to act as a reservoir. It is going, when you charge it up, it is going to hold a charge, and then when you remove that current from where you put the charge into it, it will discharge. So it acts as a reservoir. If you put a capacitor between your positive and negative, and you charge it up by turning on the power, when you turn the power off, depending on the capacity of the capacitor, that's how long it will be able to power your circuit. And if you've ever heard of supercapacitors taking the place of batteries, well, that's where that theory kind of comes from. They can act like batteries. One thing a capacitor can do that a battery cannot do is a capacitor can output all of its stored charge almost instantaneously. Now, capacitors are polarized, some of them. These are electrolytic capacitors, the ones that look like cans. They are most definitely polarized. Now I'm going to use some blue tack to hold them down onto the board. This is just a sticky putty that doesn't leave any residue, doesn't really dry out. It helps to hold things in place. You see, you don't need a lot of equipment to put a kit together like this. A little bit of sticky tape or sticky tack, soldering iron, some nippers, pliers or tweezers, and you're pretty much good to go. And that's kind of why I wanted to put this thing together, to talk about, you know, people might be getting these for Christmas and not be all that up on their soldering. This should help put things together a little bit. So while this is soldering, my kit did not come with any instructions, so I had to search things out. But let's go over the resistors for the two boards. R1 is 10K, R2 is 330K on one board, 1K on another, R3 is 10K, R4 is 1K and then 2K, R5 is 10K, R6 is 1K, R7 is 10K. All of the capacitors are the same, 47 microfarad at 16 volts. All right, so next we have the base plate we're going to put together. All we have to really put on here is the power switch. We're going to hold it down with some blue tack, which not only holds it to the board, but also helps us align it properly. And then again, I'm just going to solder a couple pins, check its alignment, come back and finish it. Then we have a 2.1 millimeter barrel jack. So this little LED Christmas tree can be powered either by 3 batteries or by a 5-volt DC input. Nothing to it. Okay, time to get the LEDs in. They're really simple, but they are polarized, so keep that in mind. The long leg is the positive leg, and in this case it goes to the bottom hole, the one facing the bottom of the tree. It can be different. Some of the footprints have a flat spot that tells you the negative side. This one doesn't. I just used my multimeter to test which one went to positive, which one went to negative, and then I put them together like that. Make sure you don't put the LEDs flush up against the board because you have to bend them over. And if they're flush, that's not going to give you anything to bend. So just pay a little bit of attention to that. And you shouldn't have any trouble at all. There are 36 LEDs, so that is going to be 72 solder joints. All right, we are down to our final stages. So the next thing we need to do is get these guys together. And then we need to solder this thing here in the center. And what I want to do maybe is stick it in here and see if that'll help hold things together. Try and get some alignment, I don't know if it will. Give me a minute to figure this out. All right, use a little bit of blue tack to kind of hold them in place. Then I just want to make sure that we're not going to have any trouble fitting this into the board. No, we're not. All right, so still have to solder those together. All right, so I'm thinking. I think the best thing to do will be to solder it into this base plate first, and then that way. So let's have a look here. That says minus plus, plus, plus. So there's my 2 pluses, like so. Yeah. This is a little tricky to put together. Just trying to figure out a way to hold it together. One moment. All right, here's how I'm going to do this. I'm going to start by tinning these pads. Let's get some flux on them first. The reason I'm going to put tin on them, or solder, when you apply solder to a surface, that's called tinning it. So the reason I'm putting the tin on there first is an old saying, solder flows where solder's been. So it's always better to tin. It'll make it easier to connect the board by already having some solder here. I don't want a lot because I don't want it to be lopsided. I just want to coat the board, or coat these pads rather. I think just something like that. Now, plus. My idea might not work out so well. It might be a little, yeah, hang on. Flip the old cup over, how's that? So you're a plus, those are pluses. Okay. Man. It just does not want to really go in there very well. So I'm trying to pull this off. This is not particularly difficult, it's just... Alright, so if I put this one in here like so, then I should be able to slide this one over the top, right? Yes. That's how we're going to do it. And we'll just hope it works. Alright, I think this is going to be alright. So this is why instructions can be quite helpful. Now these connections are electrical. Alright, let's put in the other one. Positive. Just trying to get it to fit. There we go. A little bit of manipulation, I got her in there. So let's get it soldered up before anything bad happens. All right. So that leaves us with a final LED for the top of the tree. Oh, I forgot to do my little centerpieces here to keep the tree together.
there's two little like that. Let's see if I can get you a better close-up view on this one. There we go. You see, there's not much to it. We've got... That was fun. Yeah, I think just don't want to stay. There we go. These little pads aren't electronic. They're just keeping it together. All right, so now let's put in our final LED. Making sure to line up the positive and the negative. I'm not even sure that's supposed to be there. Hang on. Yep, one goes on the top. Now it gets a little trickier to solder just because you have to get in here. But it shouldn't be too bad no matter what. We're almost done. So take this one, bend it straight up. All right. So all we have to do now is put on the battery, but let me see if I've got an adapter that'll fit this. No, I don't, but that's no big deal. I'm just going to bolt this on. There's nothing to see here. All right, it's a moment of truth. Put some batteries in here. Oh, almost lost that one. Ooh. Let me turn some lights off. How about that? All right, guys, if you enjoyed this, I hope you'll give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to all the patrons. Big thanks to my friend who sent me this. That's it. I'm out. Peace.